Today, so we're doing 9.1a. We're starting sequencing and notations and probability. So Unit 9 is kind of a big one, but it kind of follows the exponentials that we talked with in the last unit. It expands on it a little bit more. It's more like if you know the last unit, you should be good for this unit. Sequencing. So let's say we have a value a sub n, right? And we want to say a sub n equals 1 over n. Well, if we put in any value for n, so let's say n is 2, okay? So let's say, or we want to say a, in this case, we want to say a of 2. A of 2 would be just 1 over 2. We replace that 2 wherever that n is. So a sub 3 becomes 1 over 3. A little bit more complex. What if we have, let's say a sub n equals negative 1 of n plus 7 on the exponent and n squared plus 7 in the denominator. Well, a sub 2 in this case, we'll just plug in 2 wherever n is. Well, that is negative 1 to 2 plus 7 is what, 9 over 2 squared. That is 4 plus 7. So that is negative 1 over 11. So negative 1, 11 is a sub 2, and so on and so on. Another interesting one is if we had a sub n, let's say, equals a number, let's say 7/5. Well, it doesn't matter what, in this case, what let's say a sub 2 then is 7/5. And a sub 3 would also equal 7/5 because a sub n equals that constant. Any value that you put in for n will equal that constant. Okay, let's go on to the part that is going to be the most complex for us in this case, and that is for when a sub n, we have to find the function for a sub n. So some rules that you might want to consider. The most important rule is to consider how the numbers change from one number to the other, and that will give you the biggest hint on what we're dealing with per se. So let me give you an example. So let's say we have a series of numbers, negative 3, 0, 5, 12, and 21, and so on. And let's assume that n begins with 1. So n begins with 1, and then this is 2, this is 3, this is 4, this is 5. So from 1, 2, 3, 4, 5, we input those numbers, right? If we had an x input output numbers per se, if I put those in to my n input, I'm going to assume that we say an x and a y, input those numbers, then that's what we get. If we put in 1, we get negative 3, we get 2, we get 0, we put 3, we get 5, if we put in 4, we get 12, and we put in 5, we get 21. So one thing you could do is you could quickly graph this, because the numbers are for me right now. I wouldn't know right away what it is, and I can quickly graph this off of the top of my head. Like, I don't have to make a great graph, but a semi-accurate one. If I have no idea what I'm dealing with, I can quickly graph it. That's one way. Here, 1, negative 3. So if I go over 1, that go down 3, 2, 0, 3, 1, 2, 3, 4, 5, 4 goes up to 12, 5, 6, 7, 8, 9, 10, 11. So all the way up here. So I noticed that this is growing pretty quickly, but it's not growing, if I hit this together, it's not growing at like a constant rate, right? This wouldn't be a line. From 3 to 0, this increases at a rate of what? From 3 to 0, it increases at 3. And this increases by 5, and this increases by 7, right? And this increases by 9. So not quite a linear equation. The slope isn't the same each time. But I noticed that 3 to 5 to 7 to 9, the amount that increases, this might be a parabola, right? Because it only increases a little bit more. It's not an exponential increase, so this might be parabolic. So like some kind of x to a certain power. So now we have to think about what could I put in to the first unit that would give me negative 3, right? If I put in, so let's say here, if I did a sub n equals, well, negative 3, what if I subtract 1 minus 3, let's say a sub 1 equals, well, I want negative 3, so that needs to be 1, minus 4? That gives me negative 3. Well, then let's think about a sub 2. gives me 0. Well, I need it to beyond 0, right? So somehow this has to become a 4 minus 4 equals 0. Well, what 2 from 2 can I do to make it 4? Well, isn't that 2 squared? Well, this is the same thing as saying 2 squared minus 4 equals 0. So this tells me that if I use the formula a sub n equals n squared minus 4, it should be, all the other values should fit. Right, if I put in 1 squared minus 4, that gives me negative 3, 2, 4 minus 4 is 0. If I put a sub 3, I'll check my numbers. 3 squared is 9, 9 minus 4, that gives me 5, which matches my value up here. So I know for sure that my function should be n squared minus 4. Let's go try some other practice one. Usually, mostly these are just kind of like test and basically test and non-test. So let's try another one. Let's say a sub n equals a set of numbers. Let's say 93, 86, 79, 72, 65. Well, I noticed that this is decreasing, right? I know this is decreasing, but it's not decreasing by a whole lot. But let's see how much it's decreasing each time. From 93 to 86, it is decreasing by 7. So this, I notice here this is decreasing by 7, and from 86 to 79 it's also decreasing by 7. So I see a linear pattern here because everything's decreasing by 7. If I start at 1, right, a sub n equals 1 of 1. So let's say a sub 1 should equal 93. Well, let's think about this. We are subtracting 7, so my slope needs to be 7. Does that make sense? So our slope should be negative 7, and I need to start off at 93. So let's think about this. 93 plus 7, right? We need 7 above. I'm going to add 7 to that, so then that makes it 100. So it's a linear equation. I know it starts off at 100 because a sub 1 starts out of 93. So that means a sub 0 should be 100. Subtract 7, get 93, and so on and so on. And I imagine if you check your numbers, it should work, right? Continuing on with some other examples, let's say here, how would we know if we have, let's say, a power function? If we have an alternating signs, right? If we have somehow it's a plus and a minus and a plus and a minus, then more than likely we have something to an exponent, because remember, all even exponents are positive. Negative exponents can also then be a negative number. So let's give you an example. So let's say we have 1/3, negative 1/9, 1/27, and negative 1/81. I know n sub 1, a sub 1 needs to be 1/3. So let's see, how do we get 1/3? Well, the easiest way that I can think about 1/3 is for 3, right? If I had 3 to a certain power, so let's say, isn't 1/3 3 to the negative 1 power? Well, there's a 1 right there, and I can have a negative 1. So if I had 3 to the negative n, and I put an a sub 1, that gives me 1/3. That gives me 1/3. So what about 2? If I put 2 in, let's see here, 3 to the negative n, that makes 3 to the negative 2, right? Do we get 3 to the negative 2? Well, that gives me a positive 1/9. So I wanted to alternate signs, but I don't want to necessarily mess with the values I have going, because I like my 1/3, I like my 1/9, and it's gonna keep growing up. So all I need to do now is just put in a negative 1, right? Because if you have a negative 1 to a certain power, it would make it negative. Well, the first one is positive, right? If I take that and I multiply it by negative 1, well, of course, it's not going to work. But if I took that negative 1, right, and let's say I take it to the power, because think about even powers here. Even powers will make that positive, right? That negative 1 positive, and odd powers will make that negative 1 negative, and that allows us to control the negative positive function. So if it's starting with a positive, I want my exponent to be positive. So I want this to say, I don't want it to be 1. I want it to be 2. So let's I add 1. Right? 1 plus 1 is 2. Negative 1 squared makes that positive 1. That gives me a positive 1/3. If I took this one to the second power, so 2 plus 1, that's 3. 3, negative 1 to the third power is a negative. That gives me a negative 1/9. So just by doing this allows me to alternate my signs to a positive and a negative. One last concept here is this. And that is, if some of you don't remember, that is a factorial. It is the same thing as saying 1 times 2 times 3 times 4 times 5, so on. But the one thing you need to know about factorial is it grows quickly, very quickly. So if you were to find a set of numbers that somehow magically grew very quickly, then most likely you are dealing with a factorial. Now let's find an example here. Let's give an example of this. Let's say we have 2. Say we have 2 over 2, 6 over 8. It doesn't grow quickly right away, but it will jump. And the numbers, if somehow you're dealing with hundreds after like a few numbers, and then close to 1,000 after 5 numbers, you're dealing with factorial here in this case. But in this case, the factorial, it's growing very highly in the numerator. So I have a feeling my numerator is a factorial. It's growing really quickly in my denominator, yeah, but not as much. So I have a feeling my denominator, not a factorial, but probably an exponential growth. So recognizing these numbers and recognizing these number patterns will allow me to figure this out. So I'm just going to focus right now just in the numerator. The numerator tells me I have a factorial, right? So if I had a sub 1 and I wanted it to be, let's say 2, well, isn't that 1 plus 1? 1 plus 1 would give me, or n plus 1, that would give me 2. Well, then what about a sub 2? Well, if I just did n plus 1, that would just be 3. However, if I did n plus 1 now, and I did it a factorial, let's see how that goes. So that means that you factorial, you do the first number and the second number. So a sub 1 would be 2. And now you multiply that with the second one, which is 2 plus 1, which is 2 times 3, which gives me 6. A sub 3, you do 2, right, times 3 plus 1. That gives me 2 times 3 times 4, which gives me 24. So my numbers are currently lining up. So I imagine my numerator is going to be n plus 1 factorial. But let's think about my denominator though. My denominator isn't growing as quickly, but it's growing quickly enough. So I know this is an exponential growth. Okay, so let's see how much it's growing each time in terms of growth. And my denominator is from 2 to 8 to 26 to 80 to 242. Well, from 2 to 8, it's growing at a rate of 6? And then from 8 to 26, it's growing at a rate of 18. And 80 to 26, it's 54. And 242 to 80, there's a difference of 162. And then notice that they all have something in common. They all are all factors of 3. They're also all factors of 2. I can test out this hypothesis by saying, okay, I think they're growing in a factor of 3, but let's try it out. Let's say I have 1 to the n power, right? So a sub 1 will give me 1. A sub 2 will give me 1. So it's not 1. That's 2 to the n power. A sub 1 will give me 2, which gives me 2. A sub 2 will give me 4, which isn't quite close enough. A sub 3 will give me 8, and the growth is not quite close enough. 2, 4, and 8 differentiate between 2, 8, and 26. So let's try the next one. 3 of n. A sub 1 will give me 3, which is close to 2, but not 2. A sub 2 will give me 3 squared is 9. That's close to 8, not 8. And a sub 3 will give me 27. It's close to 26, not 26, but I noticed that 3, 9, and 27 are close to my numbers, except I just have to subtract 1. So I have a feeling my denominator is 3n minus 1. So if I combine my numerator being, once again, n plus 1 factorial, and my denominator is then 3n minus 1, and that will be my answer for that one.